Okay, boys and girls, so we continue our lesson number 23. Okay, that day we stop at page number 9, the exercise part. So before we continue with the exercise question number 4, we come back here and recall a bit what we learned in the last lesson. Okay, we learned about Brownian motion. Brownian motion actually is to prove that evidence for the kinetic model of metal. So this one is a random movement for the particle moving in fluid. Fluid at here could be in liquid or can be in gas. Okay, so in gas we can using the smoke particle. We observe the smoke particle, then we found out that the smoke particle will change direction, move randomly, and then they are moving in zigzag path. Okay, so in liquid, so we can observe the pollen grain. Okay, pollen grain moving in the water. Okay, because collide with the water. So fluid, we got two, liquid and gas. Okay, why they move randomly movement? Okay, move randomly is because collision by the molecule of the fluid. Okay, so for smoke particle, in the microscope here, under the microscope, we saw the smoke particle, but we cannot see the air molecule. We only can see the smoke particle. Why cannot see the air molecule? They got few reason. One is because the air molecule very small, small size. Okay, it's very light, then very fast moving. It's moving very fast. Okay, so at here we only observe the smoke particle, and then the bright dot that we observe, we found out that they keep on changing direction. Okay, they travel in a straight line. When it hit by the air molecule, it will change direction until it hit another molecule again, then change direction until hit another again, then change. Before they change direction, all the time is a straight line. So you don't trying to draw any curved line. Okay, so they hit the air molecule, they change direction, then travel in a straight line until they hit another air molecule again. Okay, so under the microscope, we saw the bright dot. Actually, that is smoke particle. Again, we cannot see air molecule. We got few reason. It's because the air molecule too small, too light, too fast. Okay, so okay, this effect called Brownian motion, Brownian motion. So this sentence is very important. How Brownian's motion, the effect showing you, okay? The particle moving in randomly, okay, and zigzag path, okay? So at here we come back to our question number 4. This is page number 9, page number 9. Okay, figure below represent the path taken in air by a smoke particle as seen in the Brownian motion experiment. The smoke particle can be seen through a microscope, but air molecule cannot. Okay, we can see the smoke, but we cannot see air the molecule. Step what caused the smoke particle to move like this? How it move? Okay, starting from here, it move and then change direction, move, change direction, change. Okay, so at here, what caused the smoke particle to move like this? Answer is because they collide by air particles. Okay, they collide by air particle. That's why they change direction. So at here, actually, we cannot see, but here is air particle, here is air particle, here is air particle. When they collide particle, then they will change direction. Okay, so all this cannot be seen now. Okay, this is A. Okay, why smoke move like this? How the smoke moving? Randomly and in zigzag path. Okay. What conclusion about air molecule from this observation? We cannot see the air molecule, cannot. Okay, so what conclusion we can make? So just now I got mentioned, because our air molecule are very small. Okay, the size very small. Okay, or we can say very too small to be seen. Okay, what else? Just now I got mentioned is move very fast. Okay, fast moving. For air molecule, also movement in all direction, also randomly movement in all direction. Okay, so write it down. Why we cannot under the microscope cannot observe the air molecule? Reason is because air molecule too small, because air molecule move too fast. So we only can observe smoke particle. Okay, if you're done writing, then you press the reaction button to let me know. So I know that we can proceed. Angeline, okay. Emily, okay. Megan, okay. Oh, okay. Roughly okay, huh? Okay, Bora, okay. Bora, there is a button here, audio, video, participant, chat, and reaction. 子画, okay. Right, dear, we goes to the next page at here. Question number 5. The apparatus in the figure below is being used to view the movement of some smoke particle trapped in the box. So we trap it in, we trap the smoke particle in. Of course, inside will automatic have air molecule. Initially got air molecule. No need to trap air molecule go in, okay? Describe what is seen when the smoke is viewed through the microscope. What is seen? So at here, answer, you don't tell me that you seen smoke. They're asking you when smoke is viewed, what is seen? So at here, we say that we can see the bright dot. Bright dots. Okay? We can see the bright dot. Too much, not enough. You see the bright dot and how the bright dot move. Okay, bright dot moving randomly and in zigzag path. Zigzag path is a very important keyword. Okay, in the space below, sketch how a smoke particle might move during a short interval time. Okay, so you can start from any way. Okay, this is the smoke. Then, as I told you, you using ruler draw a straight line. Then after that, you change direction. When you change direction, please also a straight line. Then after that, change direction again. Okay, then change direction in random direction. Okay, something like that. You don't draw a regular pattern, because they will never be in regular pattern. Okay, they in random directions, so you can go any way. Okay, I will encourage you at least you cross one of the line. Then normally, the answer scheme they were asking you at least you got 3 line. Okay, at least, let me have a look. Line represent a smoke particle moving with a change direction. Okay, so if change direction, okay. Line is straight with at least 2 changes of direction. So this is answer scheme. They want you draw the line. Okay, change direction 1 mark. And then here, line is a straight with at least 2 changes of direction. At least you change 2 times. Okay, then I will encourage you one of the line, you cross the other one. Okay, so this is how we draw the movement. Okay, the Brownian motion movement. What caused the smoke particle move? You see, when we do more partial question, the question that they ask is almost the same. Okay, what caused the smoke particle to move like this? So here, what caused the smoke particle to move? Same. Okay, so we can say that it's collided. Okay, collide by a particle. That's all. It's the same answer. Okay, collide is 1 mark. You understand what happened. Okay, a particle involved with air particle. Okay, the motion of the smoke particle. What is the motion? Motion in randomly and zigzag path. Okay, randomly and in zigzag path. So these motions, we call it as Brownian motion. Okay. Last lesson, this lesson, lesson 23 is easy. Okay, is some idea that you already learned in chemistry. Okay. For this one, any question? If no question, we are going to lesson 24. Can we go to lesson 24? Megan, okay? No sound. Emily, okay? Sure, ne? Bora, how about Bora? Suddenly I have no sound. What's going on? Hui Tong, okay? Hui Tong? Hui Tong, okay? Okay. Right there, we goes to your lesson number 24. Okay, the gas and kinetic model. Kinetic theory makes the following assumption for a gas in a closed container. Okay, the gas particle inside a closed container. Okay, that means that the air particle cannot come out lah. So for this one, we want to do some explanation. We need to have some assumption. Okay, the first one, a gas consists of molecule. How the gas molecule move? They will always moving with randomly and freely. Okay, how the particle inside the box here closed container move randomly and freely. Okay, is there any specific direction? No, the molecule moving in all direction and at high speed. Okay, this is how molecule move. At when temperature increase, what happened to the kinetic energy? Okay, when temperature increase, particle gain the energy. Okay, particle gain kinetic energy, so it will be energy increases. So how it move? The particle will move faster. Okay, when temperature increase, kinetic energy will increase. These two actually they are related to each others. Okay, temperature and kinetic energy is related to each others. Okay, so when kinetic energy increase, it will move faster. So here, as temperature increase, kinetic energy increases. Write down. So we need to know how the molecule their properties are. Okay, since the container is closed. Okay, so we trap it. We cannot let any gas particle come out. Okay, the total number of molecule is constant. Let's say inside at here, we got 20. Let's say we got 20 of them. So, because you are close, so this 20, they cannot escape, cannot be escaped. So this amount is the fixed amount, okay? Therefore, the mass, because number is the same, of course, your mass also constant. For example, in one classroom is 30 students, so we fix. Then your mass, total mass is also constant, okay? The total mass is also constant. Okay, here this is about some assumption about the gas. Okay, 5 seconds for you to complete. Angeline, okay. So it comes to the question number 2 here. Okay, here in terms of momentum, still remember what is momentum or not? Can you tell me what is momentum formula? Any of you tell me what is the momentum formula? Previously we learned momentum. Angeline, momentum, what is momentum formula? Yes, okay, momentum is mass times velocity, correct? Okay, so boys and girls, this one number 2 is very important. In your IGCSE paper 4, they like to asking these kinds of questions. Okay, in terms of momentum, can you explain how the gas exert pressure on the wall? Pressure on the wall. This wall is a solid, am I right? So pressure on the wall is P equals to F over A. They're asking you in terms of momentum, explain why this pressure can be produced. So boys and girls, at here, you think pressure is force divided by area. Where is the force come? Okay, still remember force equals to what? Any of you can tell me? We want to think how we relate momentum. So any of you can tell me F equals to what? Any? Already forget all the formula? Cannot be. F equals to, previously, the most easiest one, second law, MA, am I right? So if I don't want to A, because I want to include the momentum. So there is one impulsive force. MV minus MU divided by T. Do you still remember this? This one is related with the momentum, you see. Okay, so at here, force is the rate of change of momentum. So this one is actually is change of momentum. Change of momentum. MV minus MU is changes of momentum. Okay. So at here again, Change of momentum is because of what? Okay, it's because the particle collide and rebound, collide with the wall. Hit and rebound, Okay, so boys and girls, you see, do we need to memorize? Actually, if you study smart, you understand. So you no need to memorize a lot of things. We can, from this pressure, then we think what is the previous step. So force. So we explain about force. So force, I explain in terms of momentum. Force is rate of change of momentum. So at here, there is a change of momentum. Why there is a change of momentum? It's because at here. So boys and girls, you look at this. This is the wall. Okay, this is the wall. So this is the particle coming. Particle got mass and then it got starting velocity u. Okay, I write it here u. So when it collide and then it change direction, collide, hit and rebound, it will change direction. So this velocity will not be the same. Even maybe their speed is the same, but because velocity is vector quantity, so that means that it change direction, the v will be different. Okay, so at here, when it hit the wall, okay, we will having mv minus mu. Change of momentum will be happen. Okay, so can you see that my notes at here? First things, what happened? Molecule collide with the wall. Second thing, when it collide with the wall, what's going on? Change of momentum. So it's mv minus mu happen. Okay? Then change of momentum per second, or we say rate of change of momentum, meaning that mv minus mu divided by t. What we produce? Producing force. So third point, you say that a force is produced due to the rate of change of momentum. Okay, the last one, how we produce the pressure? The force acting on the area produce pressure. So this four step is very important in terms of momentum, how the gas exert the pressure. Okay, so answer is number one, the gas molecule collide with the wall, change of momentum happen, the force is produced due to the rate of change of momentum. Pressure is produced when the force acting on the area. Okay? So if you understand the concept, no need to memorize, but using my method just now at here. Okay, P, then how we get P? Related with F. How we get F? Related with change of momentum. And then why there is a change of momentum? Because it collide with the wall. Okay, for this one, is that clear? This is important, this part important. Okay, is that clear? Any of you? Yes, Megan, okay? Megan only? The rest of you, is it okay? Suha, okay? Emily, okay? Okay, like dear, here. Because hit the wall, so we got the pressure. Am I right? We hit the wall, then in between, blah, 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 final, we get the pressure, right? Okay, so the more often the particle hit the wall, they will more, the higher the pressure. Okay? The more often hit the wall, the higher the pressure. Okay? The higher the pressure. The more often the gas hit the wall, the higher the gas pressure. Okay? Because just now we say hit the wall, produce pressure. So if you hit more, then higher pressure. Okay, this is why the pressure in a tire or balloon goes up when more air particle pump in. When more air particle pump into the balloon, you blow the balloon will getting bigger and bigger. Why? It experience higher pressure. Okay, more particle collide with the wall. So the balloon getting high pressure, it will trying to expand out. Okay, so gas pressure is because the particle collide with the wall. If no question, we goes to your page number 2. Is it okay? Should be okay, right, dear? Okay, here. Thank you. Okay, what is the factor affecting your gas pressure? So just now we say gas pressure is affecting by what? collide, collision, okay? Collision, or we say collide with the wall. Okay, we will be affected by three. One, two, and three here. Okay, here number one, affecting by volume. Okay, when the volume decrease, so we look at here this one. When I push it down, so it become lower volume. This volume becomes smaller. Okay, because this is a closed container. So that means that the air particle cannot escape. Number of air particle will be the same. This one, 2, 4, 2, 4, 6, 8, 10, 12, 13. Here got 13. When I push it down into a smaller volume, this one still got 13 molecule. Okay, it won't be changed. But the problem is when we decrease the volume, the molecule that only can move in a smaller space. Okay, so as here we write down it moving in a smaller space. Okay, molecule will be closer together. They will be close to each others. Okay, because they are close to each other, and also you see, they will be get more chance to collide with the wall. Okay, they will collide with the wall more often. Okay, they will collide with the wall more often. More collision, just now we got mentioned, if you collide more, of course, you will get a higher pressure. Okay, higher pressure will be produced. So volume decrease, higher pressure. So you can imagine if this is a one classroom, so you got 30 students sitting inside. Okay, you still feel okay lah. Okay, but right now I told you your classroom have to compress until only half of the volume. So right now everybody packed together. You will feel like very stressed, teacher. I feel very stressed. High pressure, you know. Okay, so in a smaller volume, the gas particle, they will collide more often with the wall. Collide with the wall produce pressure. That's why higher pressure will be produced. Okay, so decreasing the volume increase the pressure. This is called inversely proportional. Volume and the pressure relationship we call as inversely proportional. One increase, another one will decrease. Okay, this is the first one. Second one, temperature will also affecting the gas particle. Okay, how? So you see, these two, volume will be constant. You cannot change volume. You only can change the temperature. So you look at this one. It's one to represent what? It moving faster. Why it moving faster? Because this one, it heat it. So this one get more higher temperature. Higher temperature, increase in temperature will make the particle move more quickly. Okay, move more quickly. The gas particle will hit the wall more often and with a larger force. Okay, why larger force? Because they increase the speed, what, dear? Right? They're increasing the speed. So just now we say the force is F equals to mv minus mu over T. They increase their speed already. So their force will be greater force. Okay? Every single time they hit the wall, the force that produced will be bigger than just now the case here. Okay, it will be bigger force. Then this will be increased. Collide more often and also the force is a higher force. So it will increase the pressure. Increase temperature, increase the pressure. Okay, then we goes to the third case. Let's say volume is the same, temperature is the same, but I increase number of gas particle. Like what I mentioned just now, we using a balloon, then we keep on blowing, okay? Blowing, that means that you are letting the air particle go in. Okay, so when you are increasing the number of gas particle, you are increasing the frequency of collision. That means that more collision will be happen. Okay, more collision. Okay, at here I want to emphasize when in your IGCSE exam, you don't say that more collision, full stop. More often collision, full stop. No, there is one keyword collision with wall. must mention with wall, okay? Of course, not only collision with wall, a molecule and molecule itself also will collide. But then that is not causing the pressure. Causing the pressure is collide with the wall. Whatever you want to mention, you have to say that collide with the wall more often. Okay, if you say collide with the molecule and wall more often, yes, definitely yes. Okay, but if you say collide with the molecule more often, sorry, no. Must with the wall, okay? Because pressure on the wall, okay? So at the end, more number of particle, pressure will increase. That's why you blow, blow, blow. The balloon will getting bigger, bigger, bigger. It's because inside the balloon, the experience the high pressure. So trying to expand out to reduce back the pressure. Okay. So at here we can go to your page number 3. My dear, we go to your page number 3. Okay, temperature and Celsius scale. Okay, last lesson we did learning about the absolute zero. Am I right? Absolute zero, that time I told you is 0 Kelvin. So actually it's in Kelvin scale. Okay, Kelvin scale. So this one we call it as absolute temperature. Okay, if you measure in Kelvin scale, we can know it as absolute temperature. Okay, so last week I did mention about degree Celsius change to Kelvin is plus 273. Kelvin change back is negative 273. This value you have to know. Question will not tell you, so you have to know, dear. Okay, this value you have to know. Okay, so we look at this. In our previous lesson, we said that the lowest temperature, do you guys still remember? Let me find it out for you. Okay, it's somewhere here. Ooh, wait, did we mention about that? I think yes. Da, 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 da. Page number six. Oh, this one. Okay, dear, can you see that here? The lowest possible temperature is negative 273 degrees Celsius. This is lesson number 23. Okay, this is the possible lowest temperature. This temperature known as absolute zero because in Kelvin it is 0 K. 0 Kelvin, so it's called absolute zero. So temperature in Kelvin called as absolute temperature. When in 0 Kelvin, called absolute zero. Okay, so this one is what we learn. So at here, negative 273. Okay, this is the lowest possible temperature, which is known as absolute zero. My dear, write down. Okay, so you don't think that 0 degrees Celsius is the lowest temperature. No, you go to others country, when they are winter or whatever, negative something, we got the negative value for the temperature, okay? But the lowest temperature is negative 273 degrees Celsius. At this degree Celsius, actually the particle is not moving, okay? At here, the particle actually is not moving. Their kinetic energy is 0. Okay. Then at here, exercise. Simple exercise. When absolute zero, what is the degree Celsius and what is the Kelvin? Melting ice. Okay, dear, the first one. Type it. Type your answer in the chat box for me. Absolute zero. What is your degree Celsius? What is your Kelvin? Okay, type your answer in the chat box. And then the second one, melting ice. What is the degree Celsius and what is the Kelvin? Last one, the steam. Angeline, here, You means the first one or second one, Angeline? Absolute is in measure in Kelvin, measure in Kelvin. 0 Kelvin. So this one it should be 0. 0 Kelvin. Okay, 0 Kelvin. Then this one is, you see, from Kelvin, 0 change to the degree Celsius. Actually, it should be negative 273 degrees Celsius. Okay, so for the first one, absolute 0, meaning that 0 Kelvin. So Kelvin is 0. Change to degree Celsius minus 273. So this one, plus or minus, you have to know by yourself. Okay, here melting ice. Ice melt at what degree Celsius? Answer is 0. Am I right? What from ice we melt to become water. Okay, is 0 degrees Celsius. Okay, it melt at 0 degrees Celsius. So this one 0 degrees Celsius. If we convert to Kelvin, it should be 273 Kelvin. Okay, so plus it here. Then after that, steam. Steam is it convert from liquid convert to gas. Okay, converting to gas. So gas at here is 100 degrees Celsius. So 100 degrees Celsius in Kelvin plus 273. So it should be 373 Kelvin. Okay, is that clear, dear? Degree Celsius change to Kelvin plus 273. Okay, from Kelvin go back minus. Okay, so Angeline, okay, so we go to your next page. We look at the past year question here. The lowest possible temperature is 0 Kelvin. State the name for this lowest possible temperature. Easy, right? Okay, in Kelvin, the scale we call it as absolute. Okay, the temperature in Kelvin we call it as absolute temperature. Am I right? Then this lowest possible temperature we call it as the absolute 0. This is past year 2023. Okay, 2023, absolute 0. For 0K, we call it as absolute 0. Okay, nitrogen will boil at 77 Kelvin. Calculate the boiling point. Okay, do not refer. Think again. It's plus or minus 273. Count it and then tell me your answer. Megan, try to answer me. Angeline, correct. So think is plus or minus. Okay, so at here 70 degrees Celsius to Kelvin. Okay, we will be plus 273. Okay, from Kelvin, we need to minus back. Okay, so dear here, 77, you from Kelvin go back to degree Celsius. Okay, so we need to minus 273. So your answer should be negative 196 degrees Celsius. Megan, correct. Yes, correct. Negative 196 degrees Celsius. 2 marks, please show working step. Some of you mathematics is very good. In your brain, you already count it and then minus it, then you get the answer negative 196. But please show working step. Okay? So here, the temperature of a fixed mass of gas at constant volume, it change. Okay, temperature change. The specific mention, volume doesn't change. You want to study something, you cannot like change temperature at the same time you're also changing the volume. Cannot. Then at the end, the effect is belongs to the volume or belongs to the effect of temperature. So every time we want to study the effect, okay, for example, temperature, how temperature affecting pressure. The rest of the variable, you have to make it constant for a fair comparison. So volume must be the same. Number of particles inside must be the same. Okay. So at here, state and explain in terms of particle. So you need to mention what happened to the particle. Okay. The effect on the pressure. Temperature increase. Effect on the pressure. Pressure will be, so write your answer in the chat box. Pressure will be what? Then Y. 4 mark at here. How you are going to score the 4 mark? Can you try? Try. My dear, try. Temperature increase in terms of particle. So explain. What is the effect on the pressure? You try, huh, dear, try. So that I can understand that whether you understand what we learned today or not. Any of you? Do not just keep quiet and waiting for my answer, dear. Okay. Okay, let me check Angeline answer. Pressure will increase. The particle gain kinetic energy, causing them move faster. They collide with the wall more often. Okay, you score 3 mark. You need one more point to score 4 mark. So you got 3 points already for Angeline. So Zihua said kinetic energy between the particle will increase. Kinetic, yes. So the collision between them more often. 2 mark. And then some more you didn't tell me what is the effect on the pressure. The statement here is actually what is the effect on pressure. So Zihua, you only score 2 mark. So dear, yes, increase pressure. Pressure will be higher. Pressure. Okay, so at here, this is how they move. Okay, the particle move. Okay, then when 400 K, that means that they will move faster. Okay, here the answer at here, they want mass is you mentioned about the particle, what's going on. Angeline, yes, the last point, yes. Emily, the higher the temperature, the more kinetic energy gained by the particle. Yes, 1 mark. Collision with the wall more often, increase in the gas pressure. Yes, Emily, 3 mark. Same thing. Okay, 3 mark. So you need to give one more point. So at here we mention gas particles move faster, okay, or you say that more kinetic energy. This one must have 1 mark. They want you must mention about this in terms of particle. The particle move faster, the particle move more kinetic energy. These two, they belongs to 1 point, because more kinetic energy, it will move faster. Okay, so this one is 1 mark, 2 mark. Then just now, Angeline and Emily both got mentioned about collide with the wall more often. Okay, particle collide with the wall more often. Yes, 3rd mark. But we always answer by referring the mark allocations for the mark at here is 4 marks. That means we need one more point. What else? Okay, just now I got told you, if they move faster, the speed will be increases. So the force hit on the wall, mv minus mu over t. The force here also increase. So at here we can say that greater force, gas particle cause a greater force acting on the wall. Okay. So at here, pressure is equals to force divided by area. Okay, this is one more point here. Sometimes, when you don't know what is the point you can write, you can try writing the formula. Sometimes like formula for this pressure, how you know about the pressure? Actually from here, they also can giving you mark. Okay, for this answer scheme, one of the point that accept if you got mention about this. That means that you hit this, and then one more point. Maybe you don't know about the force, but you writing this, pressure is force divided by area. Okay, this one is also 1 point. Okay. So, dear all, is it okay for this? Okay, then we goes to your page number 5. Okay, we goes to page number 5. So this one is related. This question is related with temperature lah. Next, what we need to learn this subtopic is called Boyle's law. This one is important. Okay, in your IG is quite important. Boyle's law is actually relate pressure and volume. Pressure and volume. Okay, so just now we said that volume decrease. So we're trying to push it down. So the number of particle inside does not change. Does not change. Okay, volume of the gas is decreased. Molecule will move in a smaller space. Then molecule will closer together. Particle collide with the wall more often. You see, must mention collide with wall. You don't say that particle collide more often. Collide what? What they collide. Okay, so a higher pressure will be produced. More collision, more pressure. Okay, volume decrease, then the pressure will increase. They are called inversely proportional. Can you see that? Inversely proportional. Boyle's law states that pressure is inversely proportional to its volume. Okay, can you see that at here? Fixed mass of gas, temperature is keep constant. Because just now we learned about factor affecting the pressure. We said they got three. One is volume, one is the temperature, one is the number of particle. So right now we are going to study about volume and pressure. Then the another two must be fixed. So temperature must be constant. The number of particle must be the constant. Okay, so this is the things why they got mentioned. Fixed mass of gas and temperature is keep constant. Okay, inversely proportional. So this one, you see the graph at here. This is called inversely proportional. Volume become bigger. Okay, let's say here is 10. Here is 1. Okay, volume become bigger, then pressure become low. Here, volume big, then pressure at here is low pressure. When volume is small, pressure become high. So this graph, after they sketch it out, they found out that the graph is like this. Okay, you need to know pattern of the Boyle's law graph. Okay, you need to know. Okay, but from here, this graph, we cannot get a formula. So if we want to get a formula, we need to have a straight line. Okay, we need to make it become straight line. How we make it become straight line? So they're using this V convert to 1 over V. The data of V, then 1 over the data, we will find out that at the end, the graph become a straight line passing through origin. A straight line passing through origin, do you know what is their relationship? Any of you know? Can you type in the chat box? Okay, for P is what to the volume? This one, a curved one, this one is called inversely proportional to the volume. If straight line passing through origin, first lesson, I did mention about this. Any of you still remember what is this relationship? P is what to 1 over volume? Any of you can answer me? Angeline, yes, correct. Called directly proportional. Very important idea because in paper 6, we will plot graph in paper 6. Then at the end, after you plotting the graph, you might be getting like this or you might be getting like this. Then one of the question they might be asking you, is it this relationship is proportional? If your graph is not starting from 0, our answer say no. Reason, the line doesn't straight line but doesn't pass through origin. Okay, a straight line passing through origin we call as directly proportional. A curved graph, one increase, another one decrease, this is called inversely proportional. Okay, so at the end they will get this formula. P is directly proportional. This one symbol is meanings directly proportional in mathematics. Directly proportional. Okay, in order to make this symbol to become equal symbol equation, so we need to add a constant value, which is k. Okay, which is k. So at the end, they move the v goes to another side at here. Okay, this one for those who are very good in physics and mathematics. This one is showing you how we get the formula of Boyle's law. But if you are not good in physics and not good in maths, it's okay. You don't need to know about this also, never mind. Okay, you just need to know the formula that we get is P1 V1 equals to P2 V2. Okay, the initial pressure times volume, it will be pressure times volume at the moment. You times it together, it will be a constant value. Okay, then after that you change the volume, you times at the moment the pressure, times it together, you find out that these two actually is the same value. Because pressure times that related volume, they are actually a constant number. Okay, so at here starting small, let's say starting is small volume, pressure is very high, so you times it up together, you found out that it will equal a value here, let's say it's 3. Then after that I increase the volume or decrease the volume times with the related pressure, you will find out that it will getting back the same constant value. This is the meaning. Okay, so at here, okay, they might be have one more type of graph, is something like this. Okay, I change the pressure. What happened to your PV graph? Okay, I change my pressure at here. Okay, no matter how you change your pressure, actually your volume will be changes related. Related volume will be changed together. Okay, then after that, what page 5? This is page 5. Where Zihua? Okay, here, if pressure at here, I change my pressure. What happened to my P times V? Here, boys and girls, P times V is a constant number. No matter how you change, another variable will be changed accordingly. Okay, so at the end for this graph, it will be a still horizontal line. No matter how you change your pressure, your PV graph will be the same. Okay, it's also the same. Teacher, if I change my volume, what happened to my PV value? My answer is still a constant value. Because P times V is a constant value. Volume increase, then at the same time, pressure will decrease. Then they times it up together, they're still getting the constant number. Okay, until here, is that clear? Before I scroll up for Zihua. Angeline, okay. Okay, this formula important, dear. Okay, using your highlighter, mark it down. How we get this formula is okay. If you don't know, it's okay. Okay. For those who are good one, I tell you how we get. Actually, it's from the graph. We derive the formula. Okay. Then no matter how, we found out that P times V, it will be a constant number. That's why we can get this formula lah. Okay, like the top part here. Zihua want this? Okay, we wait Zihua for sure. Okay, there we go to the next page. Can you try with the past year question? Okay, cylinder 1 contains 350 cm³ of gas at a pressure of this. Okay, that means that this is the starting volume. So we can say V1. Okay, the pressure here, P1. Okay, V1, P1. Then the gas is transferred to cylinder 2. The pressure increased. So this is our new pressure. Pressure increase. Temperature remains constant because now we study about volume and pressure. The rest of the physical quantity, please, we need to keep constant. What is the volume for the cylinder 2? Can you do calculation? Angeline, correct. Good job. Dear, please remember write formula substitution final answer. P1 V1 equals to P2 V2. Okay, the pressure is 9 times 10 power 4 times the volume 350 equals to 1.6 times 10 power 5 V2. Make sure you press your calculator and then you get your answer 197 cm cube. Teacher, do we need to convert to meter cube? My answer is no need. If they didn't mention at here, if here is meter cube, then we have to. But if here doesn't write anything, then you can left your answer in cm cube, doesn't matter. Okay, teacher, how you know it's cm cube, not meter cube? Because here, your first one, this one 350 is in cm cube. That's why your final answer for your V2 must be also in cm cube. Okay? Okay, can you try with the question number 2? See whether Angeline able to answer or not. Question number 2. Okay, for question number 1, the rest of you, is it okay? You got the idea how the Boyle's law, we apply the Boyle's law? Is it okay? The rest of you, are you still with me? Wei Tong, Bora, Megan, Emily. Yes, Wei Tong. Zihua, okay. Emily, able to follow Emily? Yes, Bora, leh? Bora. Okay, good job. Okay, dear, here. Okay, this one is a cylinder containing air at the pressure. Okay, I know that this is my pressure, P1. Okay, the length of the air column in the cylinder is 80 mm. The piston is pushed in until the pressure rise to 3.8 times 10 power 5. Okay, this one is pushed in, so pressure become higher. Can you see that this pressure become higher pressure? So here pressure become higher. So it's 3.8 times 10 power 5. Calculate the new length. Teacher, we are using P1 V1 equals to P2 V2. But here they didn't give us any volume. It's giving us a length. How should we answer? Angeline, correct. So dear, what is the formula for volume? Volume is equals to area times the length. Am I right? Area times the length. Area times the length. This is called volume. Am I right? Okay, so at here, this one number 1 is 3.8 times, sorry, this is number 2, pressure 2. Okay, this one is 1.0 times 10 power 5. Volume 1, initial volume. Area times the length. What is the initial length? Initial length, this one, 80 mm. So 80 mm. Area times the length, okay? Equals to 3.8 times 10 power 5. Volume 2. Volume 2 is area times the length. What is your new length? Okay, just now they're asking you, what is your new length? L2. So we don't know. We are going to calculate. Teacher, I got the unknown A. What should we do? Hey dear, from starting this one, the volume here, and the ending here, whatever, at any point, at any point. This volume is the same what? You see? Right? This part, the volume is the same. So at here, area and area, we can cancel out. Is that clear? Area and area, we can cancel out. So If you do calculation after you cancel the area, so your L2 should be 21. What is the unit? Again, just now starting 80, what is the unit for 80? You're using mm. So right now when you do calculation, 21 should be the mm also. Okay? Before I start, can I straight away cross out to use? Yes, dear can. Angeline, yes. Why I explain is because I worry they don't know that volume is directly proportional to length. So I need to step by step telling them why V can be represented by the length. If you understand, you can just go for, just starting from P1, L1. So 子花 leh? Yes, 子花 correct. Okay, so dear, you see, because area is constant, it doesn't change. So that means that your length increase, then your volume will increase. So this is proportional one. So at here, you can really using your length to represent your volume. Yes, no problem. Okay. So answer at here is 21 mm. Is that clear? Can we proceed to the page 7? If I prepare some homework for you guys, will you guys do it? Dear? Will you guys do it? Yes, 子华 okay. Give me some time. I give some homework, then maybe I provided the answer for you. Then you can practice. Okay. So this one, question 2, is it okay? If okay, can we proceed to the page 7? Emily, Xuan, Licious, Hui-Tong, Megan, is it okay? We proceed to the next. Okay, Xuan, thank you. Thank you for responding. Okay, dear. Okay, can we go to question number 3? Can you try before we discuss? 30 seconds for you to read the question and then you choose the answer. Yes, Angeline, correct. Megan, tell me this question, the answer of this question. 子花嘞，子花 which one A, B, C, D will be the correct? It can be moved to the left or right, but then you have to matching with the speed, matching with the pressure. Correct, 子花. Megan, Megan, try. Bora, do you want to try? Bora? Question number 3. What is your answer? Megan, yes. Okay, dear, here we look at A, step by step. A, to the left. If to the left, volume will be small. Okay, volume will be small. If volume will be small, pressure should be increased. So this one is wrong. Okay, then to the left, pressure increase. So this part, matching. Okay, these two matching. Pressure will increase, matching. To the right, volume will be increased. If volume increase, pressure should be decreased. Okay, this one matching also. Okay, to the right, volume increase, pressure should be decreased. This one not match. So what we need to think is about the B and C. Okay, these two, B and C, for their movement and pressure is correct. Okay, now speed of gas molecule. No change or it will increase. Answer is, it should be no change. Answer should be B. Why? The temperature of the gas is keep constant. Temperature unchanged. That means that speed unchanged. Temperature unchanged. That means that let me move a bit. Okay, one more. Temperature unchanged. So your kinetic energy unchanged. Kinetic energy related with the temperature. Kinetic energy. We already learned about kinetic energy 1/2 mv squared. Kinetic energy unchanged. Your speed also unchanged. Your mass confirmed unchanged. Mass is always constant. So when your kinetic energy unchanged, speed will also unchanged. Okay, so answer should be B. Is that clear for this? Now give me a reaction, yeah, dear. The more reaction you give me, I can know about you. I can know that whether you understand or not. Okay, let's go. Can you try with question number 4? Starting the length is stopped at 50, after that 25. So what is your pressure and what is your new pressure and what is your new volume? Angeline, yes. Emily, try Emily. What is your new volume when the piston is pushed in? Emily, okay, yes, correct. Zihua, have you done? Okay, volume is area times the length, am I right? So basically, you can represent by the length one. Okay, the length here initially is 50, then here it becomes 25. Okay, volume 1 is area times 50, then volume 2 is area times 25. So what is your new volume? Volume V2, V1. I can using ratio to find it. So 25A and 50A. So area times area can be cancel. So your volume V2 over V. Volume 1, we assume this is volume V. So this one is how many? Is half of V. Okay, it's actually half of V. Or you can surely know that 50 become 25 is half lah. Now I doing this is because I want to show you in mathematic way why at the end we get half. Okay, why we get half. So at here, this one we know that the volume become half of it because your length become half of it. Okay, then after that your pressure is the same. Pressure times the volume equals to pressure times the volume. P1 V1 equals to P2 V2. Okay, the pressure one is P, volume one is, you can using the length to represent, equals to P2. This is new pressure times 25. So your P2 will be 2P. 2P. Answer will be donkey. Okay, answer will be donkey. So dear, it's very makes sense. You have to using logic to check your answer also. When this case number 2, volume decrease, so automatic you understand, wow, so packed, so many particles in a smaller space. They are so packed inside. So more collision, higher pressure. So your pressure should be 2P, 2P. The rest of the answer, this one confirm wrong because it won't be smaller. When volume decrease, it won't be smaller. Then this one, you see, makes sense what? Volume become decrease. So answer is donkey. Okay, we go to your question number 5. Can you try it right now? Angeline, yes, correct. Okay, Licious, do you want to answer me question number 5? How about others? Tell me the answer for question number 5 before we discuss. What is the formula for density? Density is mass divided by volume. This is first chapter, we learn. Okay, Zihua, yes, correct. Okay, what is the pressure? Pressure is depends on volume. Okay, here, dear. Density is mass divided by volume. Bora, good job. Yes, correct. Okay, dear, density is mass divided by volume. As I told you, we have to always remember mass is always constant. Mass is always constant. So at here, when your volume become decreases, your density should be increased. So answer C or D. Okay, the pressure, volume decrease, pressure should be higher, increase, answer should be donkey. Okay, question 5, answer is donkey. Is that clear? If no question, then we can go to question number 6. Is it okay? Yes, my dear, here. Figure 4.1 shows some gas at room temperature in a cylinder with a piston that can be moved. The piston can be moved. The gas cannot escape. So that means that number of the particle is fixed. Okay, the number of the particle is fixed. At room temperature, that means that they didn't heat it. So temperature is constant. So this question is related with Boyle's law. Okay, describe the movement of the gas particle. How the gas particle move? At start, we already learned. It moves randomly and freely, right? Move randomly and freely. Okay, this one is considered 1 mark. Okay, if 2 mark, then we write one more point. Moving in all direction. Okay, or we can say that high speed, move with high speed. Okay. Describe how the gas particle exert a pressure. How it exert a pressure. This is only 1 mark, so we straightforward. We just give the main point. Okay, why there is a pressure is because collide with the wall. Collisions of particle with wall. Okay. Don't say collision of particle only. It's collision of particles with wall. Collide with the wall because the gas particle collide with the wall. Okay, the piston in figure 4.1 is moved to the left. So based on the diagram, move to the left, volume will be decreased. Volume decrease. Okay, temperature does not change. So we fix the temperature. If your volume change, temperature also change. At the end, the pressure changes. I cannot say that it's because of volume or temperature. I cannot make a conclusion, okay? So state and explain any change in pressure of the gas when the piston move to the left. Piston move to the left. So what happened to your pressure? And explain, right dear? Try to explain. 3 marks here. Try to answer me. If none of you answer me, how can I proceed? And then I don't know whether you know how to answer or not. You write your answer, I can help you to check whether your sentence okay or not. Is there any point you miss out? I'm waiting for you guys' answer. Don't trying to waiting for my answer, right dear? Okay, Angeline said that particles are closer together, 1 mark. Collide with the wall more often, 1 mark. Pressure to increase, 1 mark. Yes, 3 mark here. Okay, state what happened to the pressure. So at here, pressure increase. Pressure increase. Okay, 1 mark at here. What happened to your pressure? Pressure increase. Explain. So at here, because molecules are closer together. Very good. This is 1 mark. Okay. Then more particle, they are more collisions with wall. Okay. This is another 1 mark. And then always give the formula pressure equals to force divided by area. Who knows? It's in the answer scheme. Okay. So you understand pressure increase. Okay, more collision with the wall, collide with the wall causing the pressure because there is a changes of momentum. Then rate of change of momentum producing the force. Okay, the force acting on the area, that is a pressure. Okay, boys and girls, if no question, we will go to page number 9. Okay, 10 seconds for you to complete this. I worry you are not finished copying. Pressure increase. If here you say volume, smaller volume, I don't accept because here already mentioned volume decrease. So if you're using the same thing, same point here, you won't get the mark. Okay, they already mentioned volume decrease. So you say that molecule closer. Okay, we go to page number 9, question number 7. Okay, dear, here, a balloon. Okay, here, the helium. So they will have a volume and a pressure inside the cylinder. Then after that, pressure, this is another pressure, temperature is the same. See, temperature is the same, okay? Then calculate the volume right now. Can you do calculation right now? Yes, Angeline, yes. Formula, substitution, final answer, okay? 3. Final answer with unit. Okay. Zihua, do you try? Yes, Angeline, yes. Wait, Zihua, wait. Okay. I'm waiting. At this pressure, volume is like this. So in another pressure, what is the volume that it can occupy in the balloon? Volume of the helium. Volume occupied by the helium in the balloon. So this one is starting volume with related pressure. Then this one is a new pressure. With new pressure, what is the volume that you supposedly have? Zihua, yes. So at here, there are 3 marks. No matter how, always write formula P1 V1 equals to P2 V2. So it's 2.6 times 10 power of 6. V 0.035 equals to 1 times 10 power of 5. Then V2. So your V2 should be 0.91 meter cube. Teacher, how you know 0.91 meter cube? As I told you, V1 is meter cube, so V2 must be also meter cube. Okay? Next question. Emily, Megan, you guys can able to follow? Can we proceed to B? Okay, so we go down here. As the balloon rises through the atmosphere, the temperature decrease. Now temperature decrease. Okay, state the effect of this temperature change on the helium molecule. So decrease temperature, what happened to your molecule? Okay, Angeline already answered me. How about others? Temperature decrease. What happened to this temperature decrease effect on the molecule? So they're asking you, molecule, what happened? Okay. Zihua, answer. Tell me the answer. Should be easy, what, right, dear? What is your answer? If molecule, the balloon here. Okay, balloon here. It go up, okay? So because from starting to ending is still the same balloon, okay? It's just letting it to rise up. So the volume does not change. In this question, is not Boyle's law. In this question, yes, this is Boyle's law because it's changed the pressure, Boyle's law. Okay, but the next question at here, they're mentioning about the temperature. As I told you, if I study temperature and others, the rest of the variable have to fix. So at here, the volume is the same thing. Just they asking you what happened to the molecule inside. Okay, the molecule actually will move slower. Okay, or we say that it will has less kinetic energy. It moves slower or it has less kinetic energy. So this is not related with the Boyle's law. Okay, this is not related with Boyle's law. Volume is the same. Number of the particle inside the balloon still the same. Okay. Okay, if they asking you what happened to the pressure, then answer pressure will be lower pressure. But now the question is asking you molecule. So we talk about molecule. It can be changed the question like temperature decrease, state the effect of this temperature change on the pressure. Then answer will be pressure decrease. Okay, boys and girls, can we proceed to the page number 10? Can we proceed to the page number 10? Yes, yeah, let's go. Okay, page number 10, question number 8. The diagram shows a gas contained in a cylinder enclosed by a piston. At first, the length is 100 cm. Pressure of the gas shown by the pressure gauge is 300 kilopascal. Oh, so when length is 100, pressure is 300 kilopascal. The area is 0.12. So describe the motion. Easy. You see, when we do more partial question, actually we understand what is the key point and what we have to know about this topic. Motion of the gas molecule. Okay, molecule move randomly. Molecules move randomly. Or we can say that molecule have high speeds. Okay. Explain how the gas molecule exert a force. Why they will have a force acting on the area? Okay, it's because force is caused by collision and rebound, collide and rebound of molecules with force. Okay. So at here, collision, we will have mv minus mu. Change of momentum. Per time, this is force. Why there is the force? Actually, is because heat and rebound. So we producing change of momentum. Rate of change of momentum, that is force. Okay? Then force acting on the area, that is pressure. Can you guys help me to calculate the force exerted by the gas on the piston? Can you do calculation? What is the force? Teacher, today we learned the formula is P1V1 equals to P2V2. I don't have the formula for force. Previous lesson, we learned about pressure related with force. So what is the formula you are going to use for us to do calculation for this? Idea try? On the piston. Angeline, yes. Yes, correct. Dear Atia, piston is a solid force. And then here, what information we have? We got the pressure, length, area, then force. So what is the formula? We can relate them together. Pressure equals to force divided by area. This is pressure in solid. Piston is solid. What is the pressure? At here, 300 kilopascal. So we write 300 kilo. Dear physics, do not forget about prefix. It's also a value. Kilo is 300. Then behind add 30 is 1000. Kilo means 1000. So this one is represent kilo. Okay, equals to the force divided by area. Area is provided 0.12. Okay, what is your force? Force at here should be 36,000 Newton. Okay, dear, here I want to emphasize This one force in Newton, this is SI unit. When Newton is SI unit, please, the pressure must be in SI unit, which is in Pascal. Then area must be also in SI unit, which is in meter square. Then the force at here is in Newton. If this question they want to trick you, they can give you in cm square. You need to do one more step to convert to meter square. Okay, if they want to trick you here, they can give 3 marks. Then one of the mark is, do you know that you need to convert 0.12 or here what is the value? Convert to meter square. Okay, so this one we don't need to do conversion is because this is in meter square. Okay, pressure unit called Pascal or Newton per meter square. See, this is meter per meter square. Okay, so Pascal is SI unit. Force in Newton is SI unit, so your area must be in SI unit also. Okay. Okay, can you guys help me to do calculation? The piston is moved so that the new length of cylinder occupied by the gas is 50 cm. Just now is 100, now is 50. Okay, Angeline asking 600,000 Pascal. Do I convert to kilopascal? No need. You want to stop at 600,000 also can. No need to purposely convert it. Unless at here, final at here, they write kilopascal, then you have to convert. Okay, if they didn't write anything, we can just leave it 600,000 Pascal. Unless here, the final here, they write kilopascal, then we have to do conversion. Okay, dear, P1 V1 equals to P2 V2. This question, they provide area. You want area times the length 1 equals to area times the length 2 also can. But dear, no matter how, the cross-sectional area is the constant value. This part, the area, and this part, the area is the same. Okay, it's the same. So at here, if I don't want to make my working step like too messy, too many things, so I can cancel area and area because they are the same. Cross-sectional area for the whole piston is actually the same. Okay, so initial, our pressure is 300 kilo, right? 300 kilo times the length starting is 100. Okay, teacher, do I need to convert meter at here? Okay, here, let me finish this one, P2 first. And then L2, this is your L2, 50 cm. Teacher, do we need to do conversion? If you want to do, also can. If you don't want to do, also can. Why? Because you look at me, 100 cm. This one, 50 cm. Actually, cm and cm, you cancel out already. So without do conversion, both sides don't do. If you want to do the conversion, 0.1 m, 0.5, 1 m and 0.5 m. You will find out that answer is the same. Okay, answer is the same. So at the end, this one cm and cm can be cancelled. So that means that we no need to purposely convert the cm to m. It's different with what we know just now at here. Because my final answer here in force, then this one is in Pascal SI unit. This is SI unit. That means here also SI unit. I don't have nothing for it to cancel. Okay. So at here, your answer for your P2, it should be 600,000 Pascal. If you don't believe me, you can also trying by convert it into what? Into 1 meter, okay? Equals to P2. This one is 0.5. At the end, your answer will be the same. If let's say here, they write kilopascal, then our answer will be 600 kilopascal. Kilo represent 1,000. But if here they didn't mention anything, then we can write 600,000 Pascal. No problems. Okay, for this, any question? Any of you got any question, dear? Yes or no, dear? Yes or no? No response. Again, no response. My dear, give me some response. Thank you. Thank you, Hui Tong. Okay, dear, one more last question. Okay, Megan, thank you. You respond, then I know that you understand what I thought. Okay, so dear, explain in terms of behavior of molecule. So talk about the molecule, why the pressure has changed. You see, starting 100 cm, pressure is 300 kilopascal. Now become 50 cm, why the pressure is changed? Any of you can answer me? Why? What happened in terms of the behavior of molecule? Why the pressure has changed? Molecule, what's going on? Why it causing the pressure changes? Okay, why molecule cause pressure change? Like dear, answer me. Molecule collide with the wall of the container more often. Yes. Okay. Why pressure will change? Because molecules collide with wall more often. Yes. Okay. So therefore, the pressure will be changed. Collide more often is because right now your volume decrease. So pressure increase due to the more collision with the wall. Okay, sometimes they will say that collide with higher frequency of collision. Okay, also okay, no problem. Okay, dear. So if no question, we will stop at here. Then next week we will continue, and then I will prepare homework for the previous lesson for you to practice. Then answer will be provided. So you try to practice by yourself lah. Okay. Then after that, next week we will complete the last 4 pages. Then after that, we will enter new chapter. Okay. So any question? Okay, if no question, that's all for our lesson today.